Okay, I would like you guys to give me the proper names for 1, for 2, for 3, 6, 9, 10, 13, and 14. All right, now there's a mix in here. Some of these are ionic, some of these are molecular, some of them need Roman numerals, some of them obviously have polyatomic ions. All of the things we talked about yesterday. So you're going to have to apply the correct rules to each compound. All right, so I'll give you a few minutes to get ahead of me, and then we'll do the first couple and just check how we're doing, okay? And then we'll finish them up. Okay, let's look at just the first couple here so we can kind of run through the steps we would use. So first thing I want to do is identify whether this is ionic or molecular, because obviously the naming rules are different. Okay, so number 1, I've got lithium and chlorine. Is it ionic or molecular?
Ionic.
It's ionic. Lithium is a metal, and ionic compounds have a metal and a nonmetal. That fits. Okay, so now I'm going to follow the ionic naming rules. I'm going to write the name of the metal, and then the name of the nonmetal, ending in I. Okay, since it's ionic, do I need a Roman numeral for this one? I don't. Lithium only has one possible charge. It's in group 1, okay, so it doesn't require a Roman numeral. So the correct name for that one would be lithium chloride. Okay. Now, number 2, ionic or molecular? It's ionic. Yeah, chromium is a metal. It's further over, but it's here. Okay, chromium's a metal. Okay, and fluorine is a nonmetal. So we would have an ionic compound. So I would go through my ionic naming rules. I'd write the name of the metal, chromium, and then the name of the nonmetal, fluoride. Does this one need a Roman numeral? It does. Chromium can be a 2+ or a 3+, so we've got to figure out which one it is. All right, so to do that, as we learned yesterday, we look at the nonmetal. Fluorine is in group 17, so it has a -1 charge. Okay, there are 3 fluorines in this compound, so 3 times -1 is -3. That means my chromium has a charge of +3 because there's only 1 chromium there. So this would be chromium, Roman numeral 3, fluoride. Okay, questions on those two? Right, and then the third one, ionic or molecular?
Molecular.
It's molecular. They're both nonmetals. Phosphorus and bromine are both nonmetals, so I don't have to worry about any Roman numerals or anything like that. Okay, I'm going to write phosphorus because I don't need a prefix on that one. There's only one. Okay, and then I need a prefix on the bromine. Tri bromide. Okay, so there are a few things to think about each time you come across a new compound. Ionic or molecular, do I need Roman numerals? Okay, we haven't run into any yet that have polyatomic ions, but they're coming. Okay, doesn't really change for naming much what we do. All right, keep going. Why don't you get ahead of me again? So for number 6, ionic or molecular?
Molecular.
It's molecular. It's 2 nonmetals. Carbon's a nonmetal, sulfur's a nonmetal. Okay, so if I'm writing the name for this, I write carbon. Okay, I don't need a prefix because there's only one, and then I need the prefix for 4, tetra sulfide. Okay, carbon tetrasulfide for that one. All right, number 9, ionic or molecular? It's ionic. If it has a polyatomic ion in it, it's definitely ionic. Okay, plus calcium is a metal. So now if I'm going to write the name for this, okay, I'm going to write the name of the metal, calcium, and the name of the polyatomic ion exactly as it appears in my table, which is sulfate. Okay, do I need a Roman numeral on this one? I do not. Calcium is always a 2+ and nothing else. Okay, so that would be the name for that one. All right, how many people have done number 10? Okay, so for number 10, we got another one with a polyatomic ion. So it's an ionic compound. Okay, K stands for potassium. Okay, and MnO4 is permanganate. Okay, potassium permanganate. This stuff is actually used as a fungicide way back, right? Because it kept athlete's foot and stuff like that from growing on the feet of people who lived in the trenches during the wars. It only had one drawback. It stains your skin. And it's actually little purple crystals. They're actually quite pretty, and little purple crystals. But once it dissolves in the oils on your skin, it stains your skin a dark brown color. Okay? I had a kid who was doing a lab way back when, and he never, ever listened to me. Not ever. I told the whole class, guys, don't touch the little crystals, okay? Because they'll stain your skin. You can't get it off. Doesn't matter how much washing. It's like basically bleach and sandpaper is the only thing that will get it off. And this guy who never listened, he was like pasty white, okay, like borderline albino, okay? And he comes up to me with the dish and all the crystals, and he's doing this. Coder, these are so cool. And I'm looking at his fingertips, and I'm like, yeah, they are. Look at your fingertips. Dark brown, like down to the first knuckle on these 3 fingers and his thumb. And he's like, well, I'll just go wash that off. Okay. He was at this thing for like a half an hour. They were like that for 2 weeks. Okay, now imagine like dark brown on someone who's like otherwise extremely pasty. It's like, where have your fingers? Okay. Like, yeah. He listened a lot better after that. Okay. All right, how many people have done 13? Okay, let's have a look at that one. So this one also has a polyatomic ion, so it's an ionic compound. Okay, name of the metal first. Okay, barium, and then the name of this stuff, Cn, is cyanide. So barium cyanide. Okay, and then our last one here, okay, last ionic compound with a polyatomic ion in it, HCO3 is a polyatomic ion. This stuff is sodium, hydrogen, carbonate. You have definitely used this stuff before in your life.
For number 13, what did you put the 2 outside the bracket?
Nothing. Because it's an ionic compound, it doesn't affect our name because we don't use any prefixes. Yeah. Okay. All right, so sodium hydrogen carbonate, what is that commonly known as?
Salt.
It's a type of salt. It's baking soda. Okay, that's sodium hydrogen carbonate or sodium bicarbonate. That's baking soda. Okay, let's look now at going the other way. We've done all this work with here's the formula, write the name. Now we got to look at here's the name, write the formula. Right? So for molecular compounds, that's a pretty easy process. We look at the prefixes and we put the appropriate numbers in the name and we're done. Okay, so writing the formulas for molecular compounds is pretty straightforward. Okay, and then for ionic compounds, well, there's a little bit more to do because obviously we have to do the drop and swap to get the numbers right. Okay, but now you've got some compounds that are going to have things you haven't used before, like the Roman numerals. Okay, and you're going to have polyatomic ions, okay, and things like that. So our steps, okay, for writing the formulas is, okay, we first write the formula for the metal, then we write the formula for the non-metal, and we put the charges up above. Okay, then we drop and swap, and we'll get the appropriate numbers. So if we had, let's say, this compound here. So let's say I was given that name, magnesium nitride. Right? If I follow the steps that are in the notes, the first thing I would do is write the formula for magnesium. and its charge, 2 plus. And then I would write the formula for the nonmetal, nitrogen, and its charge. Okay, -3. Now what do I do with those numbers? Swap them, right? Drop and swap. So drop it here, swap it here. Drop it here, swap it there. Okay, now notice what that does. 2 times 3 is 6, 3 times 2 is 6, right? That balances my charges, right? I've got 6 positive charges and 6 negative charges. That thing we were talking about before when we were figuring out the Roman numerals. Okay, then I'm done. Okay, what if I had this one? Okay, so if I follow the same steps, okay, here's my metal. What does the 2 tell me? It tells me the charge, right? So I know that this is the lead that's 2 plus, not the lead that's 4 plus. So I know which number to use in the drop and swap. That's what it's there for. Okay, it doesn't tell me how many leads there are. It tells me what charge to use when I drop and swap. Okay, and then it's with oxygen. Okay, oxygen's always a -2. All right, now if I drop and swap this, or do I even need to drop and swap this? I don't. It's already balanced, isn't it? Okay, well then I'm done. It's just PBO. Okay, if you dropped and swapped and wrote it like this, would you be right or wrong? You'd be wrong. Okay? Is this compound the same as this compound? Okay, ionic compounds always go to their lowest possible combination. So if you end up with numbers that you can reduce, reduce. Okay, if you end up with a 3 and a 6, you reduce it down to 1 and 3. Or sorry, 1 and 2, sorry. 1 and 2. Okay, if you add a 2 and 4, same thing, 1 and 2. Reduce it down. Always reduce, just like fractions. Okay, you don't do that with molecular because they tell you these are the numbers with the prefixes. Okay. All right. What about if I had this one? Okay, so this one's got a little bit of a trick in it, something that we haven't really covered yet. Okay, so I still follow the rules. Okay, I still say calcium with a 2 plus, and then I write nitrate, which is NO3, and its charge is -1. Okay, because it's ionic, I now need to drop and swap. Okay, so the -1, the 1 would come here, but we don't write 1s, so I'm done with that number. And the 2 goes here. But if I write it like this, what does that say? It's saying there's 32 oxygens. Is that what I want? No, I want to have 2 nitrates. That's why you saw on the last, or on this slide further up, that there were brackets around the polyatomic ions. Okay? It works like math. I enclose something in brackets if I want the number beside it to apply to everything in the brackets. Okay, so that's what we're doing here. This says that there's 1 calcium and 2 nitrates, rather than saying 1 calcium, 1 nitrogen, and 32 oxygens, which is vastly different than this. All right, so that's the little extra trick that we have to remember, is if we're doing this with polyatomic ions and we have to put a number beside the polyatomic ion, we have to put brackets around it so it applies to all of it. Okay, so the same would be true if I had this one here. So okay, if I had beryllium hydroxide, I would do the same thing. I would write beryllium with its charge and hydroxide with its charge. Okay, and then I would drop the 1 and drop the 2 and enclose in brackets. Okay. Now, if you had a polyatomic ion and you put it in brackets and you didn't need to put a number beside it, would it be wrong? The answer is no, it wouldn't be. It would be like you had a 1 outside the brackets. We just typically don't write brackets if we don't have to, but it's not wrong to do so. Okay, in fact, you can see that further up on this, or on the last slide here, come on. Okay, I actually had one here where I didn't need a number outside, but I still put the brackets around. Same with potassium permanganate. I didn't need to put a number outside, but I enclosed them in brackets anyway. It's not wrong, but we don't typically do it if we don't have to. Okay, like we said, doing this for molecular compounds is really easy. You just use the prefixes to tell you what number you're going to put in. Okay, so if I have, let's say, if I have triphosphorus dinitride, okay, I write phosphorus with a 3 and nitrogen with a 2. Done. That ringing a bell? Okay, so I don't remember if I put this in your notes or not. I don't think I did, but this was just the kind of shorthand of what I had on the previous slides. So it's already on it is in your notes, just in a bit longer form. Come on. Oh, no. Okay, so our first one here, we got calcium and phosphorus. So is this ionic or molecular? It's ionic, okay? I don't see any prefixes either, okay? But I need to identify whether it's ionic or molecular so I know whether I need to do the charge balancing or whether I just need to write it out. All right, so calcium and phosphorus. Okay, phosphorus is a -3, calcium's a +2, so we simply drop and swap. Ca3P2. Okay, now, how important is it for you to be able to do this consistently? It's super important, because when we start getting into writing out chemical reactions, if we don't get the formulas for the products and reactants correct, we won't be able to balance the reaction correctly, okay? And you go from having like a reaction that's out of 4 marks and you can only get 1. because you've got one thing wrong in it, which means the stuff on the other side of the reaction is also wrong, and then the reaction's not balanced, so there's like 3 marks gone, okay? So being able to do this, and for mole equation calculations, which is the very end of the unit, if I don't get the formula right, I don't put in the right number of calcium masses, or the right number of phosphorus masses, I get the question all wrong, okay? So this is one of your like fundamental skills for chemistry, okay? It's like being able to dribble a basketball to be a basketball player, okay? Like it's that important. It's fundamental for what we do. Okay, for number 2, cesium oxide. Okay, so formula for cesium, Cs, okay? And it's with oxygen. That's an ionic compound, so I've got to write the charges, okay, like so, and then drop and swap. So CS2O. Okay, questions on that one? Okay. All right, so we got one that's got a Roman numeral now. All right, so we got manganese with oxygen. Okay, it's an ionic compound because obviously we would only have Roman numerals if we have metals. Okay, so manganese is Mn, and the 4 tells me to write +4 up here for my drop and swap, and it's with oxygen, which is a -2. Okay, now when I drop and swap, I'm going to get 2 and 4. What do I need to do with that?
Make it like 1 and 2 instead.
Exactly, I got to reduce it. 2 and 4 can be reduced down to 1 and 2. Okay, that would be the correct formula for that compound. Mn2O4 would not. Okay, number 4 is going to have a similar thing going on with it. Okay, we've got iron 2 sulfide. Okay, so it's ionic, and the Roman numeral tells me this is the iron with the 2+ charge. It's with sulfur, which is a -2. So 2 and 2 equals 0. I'm done with that one. All right, and number 5, we actually talked about this stuff. This is the purple crystals that stain your fingers. Okay, so this is potassium, which is +1, with permanganate, MnO4, which is a -1. Is that compound okay if I just get rid of the ones? It is, yeah, they're already, charges are already balanced. If I wanted to, I could enclose the MnO4 in brackets, but I wouldn't have to. All right, how are we feeling about these? Okay. All right, what do we got here? 1109. Okay. I want you guys to try the ones I circle here. So 7, 8, 11, 14, 15, and 16. So 5, 7, 8, 11, 14, 15, and 16. compounds. All right, so for number 5, we got potassium. Oh, sorry, we already did number 5. For number 7, we got copper 2 hydroxide. So copper's a metal, so we're dealing with an ionic compound. Okay, the Roman numeral tells me that this is the copper with the 2+ charge, and it's with hydroxide, which is a polyatomic ion. Sometimes that can be tricky because we're like looking around for an element name, okay, and we're not finding it. So if it ends in I, that's when it's tricky. If it ends in ate or ite or something like that, you know you're looking for a polyatomic ion. So sometimes these can be a little bit tricky. All right, it's OH and it's -1. So when I drop and swap, the 1 is gone. I put brackets here with a 2 outside the brackets, so that it's showing 1 copper and 2 hydroxides. Okay. All right, number 8 has got that 1 polyatomic ion that we said is positively charged and thus acts as a metal. Okay, so as always, I would write my metal first. My metal just happens to be ammonium this time, and its charge is +1. And it's with sulfur, which is a -2. Right, so when I drop and swap, I'm going to get a number beside the ammonium and nothing beside the sulfur. Okay, so even if there's like weird things with brackets and things like that, are the rules essentially still always the same? Right, metal first, non-metal second, drop and swap. Like if you can remember those things, there's not too many places where you can go wrong. All right, and then for number 11, we got mercury 1 sulfate. So mercury is a metal, but it has a Roman numeral. So they're telling me use the +1 charge, and it's with sulfate, which is a polyatomic ion, and it has a -2 charge. All right, so when I drop and swap, I'm going to get a 2 here, a 1 there. If I wanted to, I could put brackets in there, but I don't have to. If you got questions on these as we go, guys, don't be afraid to ask, okay? How many people are done 14? So for 14, we've got zinc, okay, and it's with hydride. What is that?
Hydrogen.
Hydrogen, yeah. It's hydrogen acting as a non-metal because it's listed second. And remember we said hydrogen can do that from time to time. It can behave as a non-metal. So hydrogen in this case has a -1 charge. How did I know not to write +1?
It's not a metal, right?
Yeah, it's not acting as a metal here. It's acting as a non-metal. So I have to use this non-metal charge. It can be a little bit tricky. Okay. All right. So zinc is acting as a metal and it has a +2 charge. So when I drop and swap, ZnH2. Okay, number 15, we finally got one of these. We've been doing nothing but ionic compounds, so we finally have a molecular compound. We have diphosphorus, so P with what number beside it? 2. Pentaoxide, so oxygen with a 5. Right. And then lastly, aluminum phosphate. Okay, so that's going to be ionic again. Okay, so aluminum has a 3+ charge, and it's with phosphate, PO4, which I believe is -3, right? Yeah. Okay. So now when I drop and swap, 3+, 3-, I'm done. Okay. Don't need to put anything down there because they already added up to 0. Okay, and again, the whole purpose of that drop and swap is to make sure that all the charges work out to add up to 0. Okay, how are we feeling about writing the formulas? Okay, good. All right, then. I think the little hamster that runs my computer is on strike. Super slow today. All right, so this, back to naming here, guys. I want you to do 3 of these. I'm just going to pick 3, and then I'll talk to you about what we're doing next week. So let's go with 4, 9, and 11. So for number 4, we got an ionic compound. Okay, so we write the name of the metal, calcium, and the name of the polyatomic ion. Sulfate, I think we've seen that one before. Okay, and for number 9, hydrogen is acting as the metal, so this is an ionic compound, hydrogen nitrate. Okay, guys, in Google Classroom, I posted the key, or I will post it, it's coming up. I'll post the key for all of the naming worksheets and formula worksheets in your worksheet booklet. Okay, so if you're wanting to practice that a little bit this weekend, you can check your answers as you go.